The distribution of nuclear weapons is split up into the following subcategories: nuclear weapon states, non-NTP nuclear weapon possessors, and states of immediate proliferation concerns. The two major nuclear powers in the world, members of the nuclear weapon states, are Russia and the United States. Russia has roughly 4,500 nuclear weapons, not including the ones awaiting dismantlement. And the United States has over 5,000 nuclear warheads. Following a peak in nuclear weapons during the mid-1960s, both countries have cut down significantly on the amount of nuclear warheads in their possessions.
In addition to Russia and the United States, the nations France, China, and the United Kingdom are also members of the nuclear weapon states. It is these countries that signed the Nuclear Non-Proliferation Treaty. India, Israel, and Pakistan, however, have not signed the Proliferation Treaty and are categorized as non-NPT nuclear weapon possessors. Iran, North Korea, and Syria are countries that are believed to possess the capability of making nuclear weapons. They are categorized as states of immediate proliferation concern.
In order to understand how nuclear weapons work, we first have to understand the structure of the atom. Atom is made with positively charged protons, neutrally charged neutrons, and negatively charged electrons. Some atoms undergo radioactive decay, and this plays a key role in the formation of a nuclear weapon. There are three kinds of radioactive decay: alpha decay, beta decay, and gamma decay. Gamma decay is responsible for creating a nuclear weapon. It occurs because the nucleus is at a high energy state, causing the nucleus to fall down to a lower energy state. When this happens, the atom emits high energy photon called a gamma particle.
According to Einstein's famous mass-energy equivalence equation, E equals mc squared, energy and mass are interchangeable. Therefore, a small amount of fissionable material can produce massive amounts of energy. In the case of the nuclear bomb, uranium is the element used for the process. Uranium has three isotopes: uranium-238, uranium-235, and uranium-234. The isotopes have the same number of protons, but differ in the number of neutrons.
Common isotope for uranium is uranium-238 with abundance of 99.2373%. The isotope used for nuclear bomb is uranium-235. In order to make a bomb, the concentration of uranium-235 should be very high, over 90%. Uranium-235 undergoes nuclear fission, which releases a lot of energy. However, this fission occurs relatively infrequently, so the reaction is triggered by hitting the nucleus with extra neutrons, causing the nucleus to be unstable and shorten its half-life. When the uranium-235 fissions, it releases 1 to 5 neutrons, causing the other nuclei to fission, creating a chain reaction.
The average length a neutron has to travel to hit a nucleus is called the mean free path. For the chain reaction to occur, the diameter of the fissionable material should be the same or greater than the mean free path. The mean free path also determines the critical mass, which is the minimum mass required for fission. The critical mass for uranium is 52 kilograms with a diameter of 16.5 centimeters. If there is exactly critical mass of uranium triggered to fission, the chain reaction will go on, but it will not create an explosion. The mass should be supercritical for it to be able to release enough energy for a bomb. This image shows the concept of the mean free path. Since an atom is mostly empty space and the nucleus is relatively small, the neutrons can pass through the atoms without hitting the nucleus.
There are two ways to trigger a nuclear fission process. First is the gun mechanism. Gun mechanism is done by dividing a supercritical mass of the fissile material into two subcritical mass and delivering one to another when you want the explosion. This is the way used in The Little Boy Dropped at Hiroshima. However, gun mechanism produces relatively low energy compared to its mass used, therefore inefficient. The more efficient mechanism is done by making a hollow sphere out of the fissile material and crushing it into a ball. The shell of the sphere should have a thickness less than the mean free path to prevent the chain reaction, while the mass should be supercritical. So when the shell is crushed into a ball, it will have a supercritical mass with a diameter greater than the mean free path, and the reaction will be triggered. The mechanism was used for the Fat Man dropped in Nagasaki.
In order to do this, the shock wave must be able to hit the tamper at the same time. So two kinds of explosives are used to achieve this goal: high-velocity explosive and low-velocity explosive. The two explosives create a lens-like effect, enabling the shock waves exerted from the detonator to arrive at the tamper at the same time. Then the shock waves will eventually crush the fissile material, causing an explosion. Little Boy had a 14.5 kiloton yield with 1.5 efficiency, while Fat Man had a 23 kiloton yield, explaining why this mechanism is preferred to the gun mechanism. The center of this blast is called the hypocenter, or ground zero. From this hypocenter, shock waves are created from the pressure of the explosion. This is called the blast effect, which is most of the total energy released by the nuclear explosion. 35% of the total energy is the thermal radiation effect, generating a massive amount of heat over 300 million degrees Celsius. First pulse lasts around 1/10 of a second, releasing radiation in the ultraviolet region. Second pulse, which lasts for several seconds, is where 99% of total thermal radiation injury comes from.
Initial nuclear radiation is 3% of the total energy. It occurs during first minute after an explosion and is mostly gamma and neutron radiation. Residual nuclear radiation is mostly from the radioactive fallout and can be hazard for months or years. Radiation can enter the ecosystem through water and air, creating long-term effects. It can cause numerous problematic symptoms, including but not limited to nausea, vomiting, diarrhea, cataracts, hair loss, leukemia, and various cancers. The biggest problem with the radiation effect for nuclear weapons is that its full extent is unknown. The United States became the first country in the world to use nuclear weapons when they bombed Hiroshima and Nagasaki in 1945. After the drop of the atomic bomb on Japan by the US, the Soviets wanted to develop its own nuclear weapons. In August of 1949, this feat was accomplished. In the years after World War II, the US had a monopoly of specific knowledge of raw material for nuclear weaponry. The nuclear arms race was a competition for supremacy in nuclear warfare between the US and the Soviet Union during the Cold War.
Nuclear weapon tests are experiments carried out to determine the effectiveness, yield, and explosive capability of nuclear weapons. Nuclear weapon tests can be broken down into 4 categories: atmospheric, underground, exoatmospheric, and underwater. This is a graph of the worldwide nuclear explosions total from 1945 to 2009. We can tell from this graph that during the 1950s to the 1960s, the United States and the Soviet Union were intimidating each other by producing nuclear arms. As the Cold War came to an end, many other foreign countries started investigating in nuclear testing.
When the Soviet Union placed their missiles in Cuba, it created great fears and panic in the United States because that means they would probably start war soon. But the results of the crisis showed that neither of the country was ready to use nuclear weapons. During 1957, United States has developed the Atlas missile that could travel 6,000 miles and land within a mile of its target. But it took over an hour to prepare for firing, thus lack of effectiveness.
Several years later, the United States overcame this problem by developing the Minuteman missile. They stored its fuel in the engines, making it able to fire in 30 seconds. The missile was 54 feet long and 10 feet in diameter, and was stored in silos under the ground to protect the country from an enemy attack. One of the biggest nuclear bombs tested by the Soviet Union yielded 50 megatons on October 30th, 1961, in Novaya Zemlya Island.
MAD is based upon the idea of deterrence, mutually assured destruction, referred to the concept of both knowing each other's capability and knowing that any attack on each other would bring a devastating counterstrike.
Amidst the Cold War, a series of treaties was issued under the Strategic Arms Limitation Treaty to curtail the buildup of nuclear weapons. It lasted from 1972 to 1979. The U.S. and Soviet Union aimed to provide broad limits on strategic offensive weapon systems. New missile programs were not allowed.
With global nuclear threats on the rise and showing no signs of slowing, the time has come for us as an international community to look at the future of nuclear weapons and technology in regards to world safety.
Since the discovery of nuclear power's destructive capabilities, many nations have taken it upon themselves to stem the tide of weapons for the well-being of the world as a whole. Australia has been a leading force in the non-proliferation movement, banning nuclear weapons not only in their area, but has called upon the UN to help tighten sanctions and move toward a nuclear weapon-free world.
Much of the world has already accepted the policies, but still states stockpile massive amounts of weapons in the name of their public safety. Many regions of the world believe nuclear weapons to be just one of the many threats facing a peaceful world and have taken it upon themselves to ban weapons that they see as a public menace rather than a tool for peace.
Many regions of the world, even with strong nuclear ambition, lack the resources to obtain such things, lending full power to the wealthy among the world, causing global unease toward those elite nations which seem to hold all of the chips. A leading cause for war among the superpowers of the world is the call for liberation of those peoples under rule of oppressive or evil regimes. This has long been the justification for the United States' continued expansion in regards to military dominance, including nuclear activities.
Before the weapons of today, there was no counter to rapid, violent expansion of a nation. Many argue that now, however, aggressive expansion and violent ambition are deterred by those peacekeeping nations with the trump card in their hand. The obvious counter-argument to this is the example of the states like North Korea, a nation that has both nuclear weaponry and the intent of violent assault on other, more peaceful nations. At the root of all these problems is the global juggernaut of the United Nations. The job has fallen upon them to keep the peace among the denizens of our planet. Thus far, countless sanctions and strict rules have kept nuclear peace among nations.